All right, let's pull back the curtain on artificial intelligence. We're going to look under the hood, and what you'll find there isn't just a bunch of code. It's a powerful, elegant mathematical engine that makes pretty much everything possible.
I mean, really think about that for a second. What on earth connects the algorithm that finds your new favorite band, to the camera that unlocks your phone, to a car that can literally drive itself? They seem like they're from totally different universes, right? Well, it turns out they're all speaking the same language. And that's the big secret. It's a universal language, a common tongue that lets all of these different AI systems see, hear, understand, and most importantly, learn about our world. That language is linear algebra. Now, don't let the name scare you off. This isn't some dusty old topic from a textbook. It's the active, beating heart of modern technology, the mathematical backbone for basically every AI model out there today. So what is it really? Think of it like this. If data is the vocabulary AI uses, then linear algebra is the grammar that lets it form sentences. It's the set of tools for organizing all that messy information into neat, tidy structures called vectors and matrices. And what are those? They're really just lists and grids of numbers. That's it. Okay, so this is where it gets really cool. How does an AI take our chaotic, colorful, noisy world and translate it into a language it can actually work with? See, an AI doesn't see a picture of a cat the way you and I do. It doesn't hear a song, it doesn't read a sentence. It understands one thing and one thing only: numbers. So its very first job is to be a kind of universal translator.
Take this image. To us, it's an image. But to an AI, it's just a giant grid of numbers, a matrix. Each number represents the color and brightness of one tiny little pixel. And just like that, a visual problem becomes a math problem.
And this process works for absolutely everything. A picture? It becomes a matrix of pixels. A block of text? It becomes vectors where numbers represent the meaning of words. The sound of my voice right now? It's just a long array of numerical samples. It all gets turned into numbers.
Okay, so once everything is translated into this numerical language, that's when the real magic begins. This is where the AI starts using the verbs of linear algebra, the operations, to actually start learning and making predictions. And you can see this perfectly in neural networks, the powerhouse behind deep learning. Their entire structure, from the moment data goes in to the final answer coming out, is just a massive, mind-boggling series of linear algebra operations. So how does it learn? Well, first the data goes in, say, that big grid of pixels from our image. Next, the network just goes to town, performing millions, sometimes billions of matrix multiplications. It's incredibly efficient. Then it spits out an answer, something like cat or not a cat. But here's the kicker. What if it's wrong? Well, the network goes back and actually tweaks all the numbers inside its own matrices to do better next time. That tiny adjustment, that's the learning part. And this whole learning thing really boils down to two key moves. First, there's transformation. The AI uses matrix math to simplify the data, to find the most important features, kind of like finding the signal in the noise. Then there's optimization. That's where it methodically tweaks and nudges all those numbers, slowly getting closer and closer to the right answer, until its predictions are incredibly accurate. I know, this can all sound pretty abstract. Matrices, vectors, multiplications. But I promise you, this isn't just theory. This mathematical language is running silently in the background of your life every single day. That show that Netflix recommended to you last night, that was linear algebra, finding patterns in a giant matrix of everyone's viewing habits. When you ask your smart speaker for the weather, yep, it's using vectors to figure out what your words mean. Robotics, catching credit card fraud, computer vision, it's all built on the exact same mathematical foundation. So we know what this language is, and we see how it works. But the biggest question of all is, why is this so critical for our future? Why does this one branch of math matter so much? This quote from the source material really hits the nail on the head. Let's be really clear about this. Linear algebra isn't just one helpful tool among many. It is the fundamental prerequisite. Without it, the AI revolution as we know it, well, it just wouldn't be happening. Period. And because it's so fundamental, it's become a launchpad for incredible innovation in some of the most important parts of our society. In healthcare, it's helping us discover new drugs faster. In finance, it's keeping our transactions secure. And in transportation, it's the core logic that allows a car to see and navigate the world. So what this all means is that understanding this language, it isn't just for mathematicians anymore. It's become the essential toolkit for anyone and everyone who's building, shaping, or even just trying to understand the intelligent world that's rising up around us. It's the code underneath the code. It's the logic that powers the learning. So now that the secret's out, it leaves us with one last really exciting question. Knowing that this is the language that these powerful systems speak, what new conversations should we start? What amazing things should we ask them to build for us next?